Have you ever sat down and thought for a minute about what an amazing feat bridge building really is? The huge expanses that are regularly crossed by just good engineering, bridging the gap so that two places that should be unable to connect to each other suddenly become immediately accessible. NSX has a bridging technology built into the distributed logical routers. And in this nugget, we're going to look at exactly what we're connecting when we build an NSX Layer 2 bridge. In order to really understand what NSX Layer 2 bridging is going to do for us, we have to think about what the bridge is going to connect. And the two separate worlds that need to be brought together in this case are going to be VLANs and VXLANs. Our existing physical infrastructure of Layer 2 switches, Layer 3 switches, providing both switching and routing, and physical routers, is usually broken down into what we think of as Layer 3 subnets. We think in terms of IP spaces more often than not, but those IP spaces are assigned and make sense because of physical separation, as we might see between a router and a Layer 3 switch, and logical separation, as we see down here at the bottom, which is defined by the assignment of VLAN ID numbers to switch ports. Those devices that share a common VLAN ID will also be assigned IP space that is common to each other. They'll be in the same subnet because they're able to communicate locally with each other. Anything that's assigned a different VLAN number is as if it was physically located on the other side of a router, even though logically it's sitting on a switch port right next to somebody in a different VLAN. And this partitioning of networks is the first type of really network virtualization that came about. And without NSX, how does ESXi support virtual machines getting onto the network? By creating virtual switches with switch ports that have been assigned what? A VLAN identifier, with a trunk port between the virtual switch and the physical switch to be able to pass those on upstream. But what have we been focusing on in this class? Not VLANs, but VXLANs. And the point of a VXLAN is a complete isolation from the physical network, with an expectation that normally a virtual machine will be connected to a logical switch with a defined VXLAN ID, and then it can route through a distributed logical router up to an edge router virtual machine as necessary, which then is able to connect up to into the physical infrastructure. Notice that with the VXLAN configuration, we are routing into the physical network, as opposed to a virtual switch with classic ESXi, where we are switching up to the physical network. One is a Layer 2 operation, the other is Layer 3. Now, we said all that to say this. What if I want a VXLAN to support virtual machines that need to be adjacent to those virtual machines that are out on the physical network, or to virtual machines that have already been set up in ESXi using a virtual switch and are on the standard traditional infrastructure defined by VLANs? Is there a way to create that infrastructure? And the answer is yes, we can. We can bridge those two worlds. And the place where that's going to happen is right here on the distributed logical router. The DLR has the ability to create a bridge interface in which it recognizes that when there's a connection to the logical switch, that it can then associate that with a switch port interface that is assigned a VLAN number. So if this little virtual machine over here on the left needs to route, that path does not need to change from anything it ever did before. But if that virtual machine is trying to communicate with its neighbors, if it's sending out a broadcast onto the network or communicating within the same subnet, then that communication not only will be distributed using the path of the logical switch, but through the distributed logical router, ESXi itself will take the responsibility of making sure that it can communicate directly with its neighbors that are sharing the same VLAN ID with any of those ports, and using the trunk port to be able to send that out to the physical infrastructure and reach those physical or virtual machines as well. Now, the two main reasons why you might want to do this are, number one, when you're in a time of transition. You're pulling your virtual machines out of the old virtual switch environment and you're bringing them into the VXLAN environment, but you've got to maintain 24/7 availability, and you can't have any offline situations that might happen midway through the migration process. So you set up a bridge so that everything is local to each other, even as you migrate virtual machines and relocate them without having to change a single IP address in the process. And then number two, This is probably the more common reason is for a mostly virtualized application or infrastructure component. You've got some things that are virtual and some that are still running bare metal. Yeah, I know, bare metal, it's still a thing. So there you go, my friend. That's what an NSX Layer 2 bridge is all about. Remember that it's only on the DLR. It's not something we're going to do on an NSX Edge device, and this is not available on a universal distributed logical router either. It's got to be a standard DLR with standard connections into a global infrastructure. I hope this has been informative for you, and I'd like to thank you for viewing.